To study hydrodynamic forces acting on floating objects in the ocean, or more specifically offshore floating wind turbines, we need some background knowledge on the design of stable structures subjected to continuous tilt due to wind, waves, and ocean currents forces. In this video, I very simply studied the stability concept of floating objects in water by discussing the center of mass, the center of gravity, and finally the metacenter to define the equilibrium states of floating objects. Let's start. The center of gravity of an object refers to the point within the object where the entire weight or mass can be considered to be concentrated. This point is determined by the distribution of mass throughout the object and is typically located at the geometric center of the object. For symmetrically shaped objects with uniform density distribution, as can be seen in this figure. However, for irregularly shaped objects or those with non-uniform density, the center of gravity may be located at a different point within the object, like the wind turbine, and the swimmer as shown here. Regardless of the object shape, the center of gravity is the point about which the object's weight is evenly balanced in all directions. Let's now talk about the stability state of a floating object. When an object submerged, either completely or partially in a fluid, it experiences an upward force that try to raise the object upward. This is buoyancy force that acts upwards through the center of buoyancy. That opposes the weight of the floating cylinder shown in this figure. The center of buoyancy is the center of displaced volume of water. For our floating cylinder, it's located at the geometrical center of the submerged part. Of the cylinder shown by the gray color here. The center of gravity of cylinder, as discussed, is the point at which its weight is considered to act. For a uniform cylinder, the center of gravity is at its geometric center along its axis, but for the floating cylinder, it is closer to the submerged part, depending, of course, on the weight and geometry, among other factors. Assume a cylinder is floating in the water. In its stable equilibrium, its center of gravity, as shown here, is positioned directly above the center of buoyancy. The center of buoyancy, as mentioned, refers to the center of the displaced volume of fluid, which is equal to the volume of the solid part of the cylinder submerged in the water, as shown by the blue color area here. Now, if the cylinder is slightly tilted clockwise, the buoyant force acts to restore it to its original position in counterclockwise direction. Note that the center of buoyancy moves towards the right from its origin. In this case, because there is a more bulk of displaced water or volume here. The restoring torque generated by the buoyant force is in the opposite direction, in counterclockwise direction to the tilt. This restoring force will stabilize the floating cylinder. We can define the stability of the floating objects using the metacenter concept. When the object is slightly tilted from its equilibrium position, as shown on the left-hand side, the metacenter is the point at which the buoyant force the red arrow intersects the center line. Which is here the dashed red line. The metacenter is shown by the yellow marker in this figure. To study the stability, we define the metacenter height, which is the vertical distance between the center of gravity and the metacenter of a floating body. If the center of gravity lies below the metacenter M, the object is in a state of stable equilibrium. In this condition, as said, when the object is tilted slightly, the buoyant force generates a moment or torque that opposes to the tilt. Causing the object to return to its original position. If the center of gravity is positioned above the metacenter M, the object is in an unstable equilibrium. When the object is tilted, in this case, the buoyant force generates a moment that further increases the tilt, causing the object to capsize even more. Note here how the center of buoyancy is shifting from its origin because the displaced volume of water is on the right hand side of the submerged part of the object. If the position of the metacenter coincides exactly with the position of the gravity, the center of gravity, the object is in its neutral equilibrium. To summarize, I give another example for better understanding of the concept of stability of floating objects. Assume we have a sphere that is filled partly with a heavy liquid and a lighter liquid, and it's submerged in another liquid or lighter fluid such as air or water. This is an object with non-uniform density distribution. This can help to define both stable and unstable equilibrium depending on the object's orientation. According to our discussion, we know roughly where are the center of buoyancy and gravity. If the sphere is positioned such that the heavy liquid occupies the lower portion of a sphere and the lighter fluid occupy the upper portion, it creates a stable equilibrium in which the center of gravity is below the center of buoyancy. Now assume we deviate or tilt the object clockwise from this position. This will result in a restoring force that brings the sphere back to its equilibrium position, like a pendulum swinging back to its rest position when displaced. On the other hand, if the sphere is positioned such that the heavy liquid occupies the upper portion and the lighter liquid or lighter fluid occupies the lower portion as shown here, it creates an unstable equilibrium. Here, the center of gravity is above the center of buoyancy. Any slight deviation from this position leads to a destabilizing force. Causing the sphere to further move away from its initial position. This is like a ball placed on top of a sharp hill. Any slight push of the ball will cause it to roll down further downhill.